Okay, great. I hope everyone enjoyed lunch. It's my great honor to start off this next plenary session with two speakers, Susan Athey and Dan Björkegren. These are both people that I've admired for a really long time, just first-rate economists doing, I think, really exciting work. And so Susan will kick us off, and then Dan, and then we'll have some time at the end for a discussion and questions. Susan, the floor is yours. Thank you.
Great. Thank you so much. Well, I'm so delighted to be here. I'm going to be excited later to share the stage with Dan, who I first met when he popped in my office as a young student at Harvard, when people were like, why are you doing this complicated stuff? And now he was way ahead of the game. And hopefully this room doesn't need to be convinced of that. So this is one of my favorite conferences. I had to miss the last 2 years. I was busy serving in government, but now I'm back, and it's just lovely to see a whole new set of people I haven't even met before. So today I'm going to talk about two projects about labor market transitions. And I should mention that I have a lab at Stanford where I try to bring technology for social impact and also evaluate it there. And that's partly to sort of get all the fun that I had when I was working with larger for-profit companies, but in an academic setting where it's easier to publish everything and sort of do that work. So a lot of this is bringing the things I've learned from industry into practice. So just as motivation, I'm going to briefly mention a paper that I've worked on with a wonderful set of co-authors using Swedish administrative data. And in this paper, we were trying to understand the impact of layoffs on worker transitions. And generally, of course, this topic, when you're thinking about AI, when you think about changes in the economy, worker transitions is, of course, a central issue. So we matched up 180,000 Swedish workers across 22,000 plant closures in Sweden to understand how layoffs impact earnings. And we used our GRF package to estimate heterogeneous treatment effects of this and break workers into deciles according to their predicted outcomes 1 year after being laid off. And so we can see that there's some decile. Everybody is sad when they're laid off, but the middle decile and especially the bottom decile are very, very sad. And the effects persist for up to 10 years. We only used the first year to train the GRF, and all of these results are, of course, out of sample as usual with machine learning models. But we also see that the things that predict 1 year bad effects also predict 10-year bad effects. And so in the paper, we show that it's a mix of firms and cities, and not one factor doesn't explain everything. But it does tell you that there are, even within firms, there are certain sets of workers who are predictably in trouble. So, if we have a lot of workers who might have difficulty making transitions, the natural question is, what kinds of things can help disadvantaged workers make transitions? So when thinking about that, of course, the natural thing to think about is training. And if we want to train at scale, a natural thing to think about is digital training, because that's cheap. AI-assisted training. These projects were started before the latest wave of LLMs, but so some kind of digital training, though, would be cheap. But of course, that's only going to be useful if getting the training actually affects getting the job. Like, the training will help once you're in a job, but you can't use it unless you get the job. And so that leads us to a lot of interesting economic questions about signaling and saying, okay, how can I credibly communicate that I have a skill? And of course, people have to, there's a chicken and egg problem, because people if you have to believe that people will value this in order to put the time in, and then enough people have to have decided that this is worthwhile in order to actually believe it's worthwhile. So in this paper, I'm not going to solve the whole equilibrium problem, and I'm teeing that up now for future discussion in the discussion question. But just wanted to give this overall framing that we're going to be thinking about solving this problem in steps. And in particular, I could imagine going to a foundation and saying, give me a whole bunch of money to try to convince people to take Coursera courses. But that would take a lot of money, okay? And that I don't know for sure that that would be a good use of everybody's time, because I'm not sure what's going to happen on the other side of it. So instead, in these two papers, we're going to be putting most of our emphasis on the second piece of this, so that then if you see things that work, you can think about scaling them. So the first project is done with a nonprofit. When we started working with them, I think they had about 5 employees, a nonprofit in Poland. And actually, if you check out on Twitter, we just put up a little interview with the founders of that organization. And so what we wanted, this was a program that was helping women get IT outsourcing jobs. So in Poland, there was a lot of growth in the IT sector, but women were not taking advantage of it to the same degree men were. So this nonprofit was trying to help women do this. And overall, there was plenty of jobs. It was just getting enough workers to get into those jobs. And so we developed a program that both hits the skill part and the signaling part, but we're going to focus more. It has probably a bigger impact on the credential part. So in this nonprofit, the question was really, can we work with them to create scalable solutions to transition more women into tech jobs? And it was Polish women, and later we served Ukrainian women as well once the war started with Russia. So what they were doing when we hooked up with them was that they had a mentoring program, and they matched women who currently had IT jobs with mid-career women who were working in other kinds of disciplines, but not in IT, and they were going to mentor them to make that transition. They did one-to-one meetings for 3 months, and they did 1 to 200 women per batch. But they run out of mentors pretty quickly, so it doesn't scale very well. So our idea, and which we proposed to them and then built and implemented, was to create a digital program. So Emil, my amazing co-author, he's co-author on both of these projects, and he's going to start at Northeastern next year, for those of you who are in Boston. He went around and interviewed some of the Polish companies and figured out what would it take to hire someone who had no experience in this field. And so they came up with the idea together of building a portfolio. So we created a program where you submit 6 assignments once every 2 weeks, and at the end of the program, you have a portfolio that demonstrates a skill. So for example, for a UX designer, at the end of it, you have a UX for an app, okay? And that, again, was something that the companies had said they would find useful. So we then we ran 2 randomized experiments, 2 separate experiments for the 2 programs, each of them at different time periods. So they're not directly comparable, although in the paper we do some things where we do pool the data. But just from the RCT perspective, the mentoring program and the challenges program had separate experiments. The mentoring program, we had an interesting experimental design problem because the mentors like to choose their mentees, and they would not be happy just to have them randomly assigned. So what we did instead was we changed it so they had to choose 2 mentees, and then we randomized which one they got matched to. So that gave us a treatment and control group of comparable people that were both selected, but they still kept the mentor happy and kept the good vibes of the program. And so we did this with 160 pairs, so 160 mentors randomized between treated and control. And then to apply for the program, you had to provide your LinkedIn profile. And the advantage of the LinkedIn profile is that trying to follow up people with surveys about jobs is very challenging. We did survey them, but we didn't get full compliance. The second experiment with the challenges program, we offered this program, the digital program. We didn't have to worry about mentors choosing. They did have to be pre-qualified. So in order to get truth in advertising and a few other things, the first 100 applicants we let in, and they're not part of our study. And then after that, we said, OK, the program is oversubscribed. And we randomized among the rest of the applicants. And so we filled up in this particular program. Then we had the 500 allocated between treated and control. After we did this, these programs both worked. Then many more people have come through the program since then, but not all randomized. Oops. So this summarizing the results. First, the figure shows over time since the start of the program, the 4 groups, the control and treated group from the 2 different experiments, all lined up in terms of months since this begins. So the first thing to notice about this, just, this group doesn't need motivation for randomized controlled trials, and I think probably most of your audiences don't need it either. But if for anybody wasn't convinced, if you tried to compare the mentoring treated group to the control group, which is the typical people showing up here, you would get a much larger treatment effect because the mentors are choosing better applicants. So the mentoring control group is better than what happens after treatment for a more typical applicant to the program. So the selection is very important. I won't show you here, but in the paper, we actually go further with this and we try to compare, like, are the mentors choosing the people who benefit most? And it turns out they're definitely choosing people who benefit more than average, but not choosing the people who we estimate would benefit the very most. And they're putting a little more emphasis on high-performing people, which makes sense. Like, that's probably those of us who are professors, we probably have a little bit of a bias in the people we take on to the people who we think are most likely to succeed. Although one thing I like about my pre-doc program is I like to hire people who maybe are a little bit less likely to succeed and I have more value added. Nonetheless, we often do put a big thumb on the scale of who's likely to succeed, because we like to look out at our charming, successful students afterwards, even if they would have done well without us, like all of my lovely students here would have done great without me too. We find large treatment effects, and you can see them in the picture. We get large effect sizes from a percentage perspective. It's very large for challenges because they have a lower baseline. We also look at heterogeneous treatment effects, and we find that the different programs have different benefits for different kinds of people. Mentoring is particularly beneficial for people with experience, and so you can think the mentoring is sort of helping them network and figure out how to take some of their experience into getting the new job, while the challenges program benefits more people who are entering the market fresh, and so building this portfolio is really necessary to kind of demonstrate the skills and get into the job. So this is an example of this program, and here we solved the chicken and egg problem with the credential partly just by brute force. Like, we went to the companies and said, like, what would you like to see? And then we created a program. But in an area where there's a growing sector, that's not a crazy thing to do, because there's some common features of what they would like to see, and there's enough people to do that. Okay, so now let me move on to the second project. And this project is more focused just on the credentialing side of things, but it's potentially at larger scale. So this project was a collaboration with Coursera. And Coursera, as you all know, reaches many, many people. We were interested in whether getting a credential actually helps you get a job. But again, if I tried to randomize people into getting a Coursera course, that would be difficult and expensive. So what we did instead is we looked at people who already had a course and tried to just focus on the impact of sharing the credential. So as you see on this page here, I've got Andrew Ng, my colleague from Stanford, and he's a co-founder of Coursera. He's put his certification on his LinkedIn profile. And so those Coursera certificates can be placed on LinkedIn, and so that's what we're going to study. So in particular, we built a new feature. Oops, I have a slide error. Let me just go back and talk about it here. So we built a new feature that helps the people get their credential onto LinkedIn. So that previously, if you wanted to put your credential onto LinkedIn, you would have to copy and paste the HTML basically and like insert it in your profile. We built a feature where with 2 clicks, it would automatically be placed onto LinkedIn, and then if you click on it LinkedIn, it takes you back to Coursera. So it's not just writing it on your profile, but it's actually taking you back to Coursera where it's certified. And so if I think back to this agenda, even if we eventually want to study the impact of the courses themselves, I don't want to spend millions of dollars trying to study that until I'm sure that I haven't got a broken funnel at the end of the funnel. So as you all know, when those of you who work in companies, like you don't want to run a big advertising campaign and bring a bunch of people in if your checkout cart is broken. Like first you fix the checkout cart, then you spend money to get people into your checkout cart. So here you can think about like getting the credentials to the job part as the end of the funnel, and then we can study bringing people into the funnel after that. So this is just going to focus on the end of the funnel, getting them after credential into the job. So another bit of framing that I think also can come up when you're doing things in companies and also when you're going back and forth between academics and companies is that there can be two kinds of research questions. And actually, if you talk to machine learners and computer scientists, they tend to think about like a recommendation system or a feature or an algorithm, right? And of course, that's what you're evaluating. So here, the feature is like I built the software for 2 clicks, and I want to evaluate the ROI on that feature. But there's another question, like a social scientist might care about, what is the effect of having a credential on your page? And that's downstream from the feature, but a social scientist might only be interested in that, and the feature is just a means to an end. And so we might be interested in both questions because we wanted Coursera to build the feature. They did build the feature, and they shipped the feature to millions of people. So the feature is out there. So the ROI was positive. That was great. We solved that problem. But also we are interested in the scientific question as well because there might be other ways to get people to get credentials on the profile, and we want to know that. So the first question we can think of as an intent to treat question in the causal language. We want to compare people assigned to get the feature to people who weren't assigned to get the feature and see what that impact is on a job. But we're also interested in the local average treatment effect, where the credential feature is a nudge that induces you to put the credential on your profile. And probably I'll come back to this, but most of the impact of getting nudged is going to be on sharing your credential, and it doesn't affect your outcomes in other ways other than the credential, because it's a nudge to share the credential, so it doesn't directly impact employment otherwise, although it might. So that's a question. The exclusion restriction may not be fully satisfied here. All right, so here's what the pipeline looks like. A Coursera learner comes in, they complete the course, they get a certificate, and we randomize at that point. So our sample is people who already got a certificate. The people who are randomized into the treatment group get a nudge. You say, do you want to boost your career? Only this percentage of people managed to complete it. Let everybody know. Add it to LinkedIn. Share now. Push the button. And then there's one more click, and then it shows up on your LinkedIn profile. And then if they don't do it, we give them another nudge. So from the intent to treat perspective, we're going to evaluate the bundle of all of that. We can't separate it apart. Then they may or may not choose to share, and then they may or may not get a job. And of course, they may or may not update their LinkedIn profile, although in this population, people generally do update their LinkedIn profiles. But we might miss people if they don't. A little more detail. When they sign up, they are asked whether they would like to connect their LinkedIn profile to Coursera before all of this happens. A small subset of people do this. So that's going to be the sample on which we measure outcomes. And I'll show you in a second that is not a random sample, but is a pre-treatment characteristic. So we're going to study that sample. We can study other things for the full sample. Then in monthly batches, so every month we would take a set of people and then send them these nudges. We then, at one point in time, do the scraping, and because of confidentiality, they couldn't share the data out, so we just had the ability to do this just one time. And so some people, we see them 6 months after they finish, some people, we see them 12 months after. That creates a little bit of messiness in the data, but that's what we have. So as I mentioned, the LinkedIn match sample is different than the full sample, and it's different in a couple of ways. So I should have mentioned, I skipped something very important. This was all trying to target disadvantaged workers, so we targeted people without a college degree or people from developing countries. We actually did a pilot to show among all the different definitions of disadvantage, this particular group seemed like this could potentially work. They were less likely to be from a developing country, more likely to have a bachelor's degree, more likely to have some proficiency, and more likely to be seeking a certain type of, to have another type of certificate already. So they're better people, the LinkedIn match sample are better than average. So these are the intent to treat effects. So this is the effect of the feature on job outcomes for the LinkedIn match sample, okay? And so we find overall about a 5.8% improvement in getting a new job. Then we define other types of outcomes that are more narrow. So the outcome is a match between pre-treatment characteristics, which is what is the certificate you're getting, and the outcome, which is what kind of job you got. So we say new job in scope is that if your new job matched the thing your certificate was in, and then new job, I'm sorry, I've got a labeling problem again. That's job in scope is the middle one, and the last one, new job in scope, is where they didn't have that kind of job before. And so we see the biggest treatment effects for those. Apologies for I made new pretty slides, but I made them for this talk. They're prettier, but not perfect, sorry. Okay, so then the next thing we do is look at the local average treatment effect results. And so we see here the first stage, which is the effect of the credential feature on sharing the credential. And that's a small effect. So in the linear probability model, so 3 percentage points change. So because we have a medium-sized intent to treat, it gets blown up by the fact that not that many people actually shared the credentials. So the second stage local average treatment effects are very large. So like 24 percentage point improvement of getting a new job as a result of actually sharing your credential on LinkedIn. And that's, of course, a local average treatment effect. So that's the treatment effect on people who had a LinkedIn profile, shared it with Coursera, and were induced to put the certificate on by the nudge. That's the group for whom this is a treatment effect, okay? So comparing people who had a LinkedIn profile and shared it with Coursera before, comparing people who were induced to get it on there as opposed to who were not. So when I look at those effects, they seem large. The standard errors are big, so we can't rule out small effects either. But part of this is really coming from the small first stage. And so we might think about our exclusion restriction again and think, well, is there some way that the nudge actually did affect the chance I got a job? Maybe the nudge also got me excited to tell people more about their credential, like tell it to emails, communicate it in some other way. So the nudge may have actually gone around my sharing after all. And that, I kind of think it may have, because those numbers seem a little too big to me. But of course, again, the confidence intervals are wide. And we're exploring treatment effect heterogeneity as well. So that's those are the big results, that actually sharing a credential does actually get you jobs. And so that suggests that maybe it would be a good idea, in fact, to sign more people up to do these courses. It might be a good use of their time. Although, of course, if everybody has one, maybe it's not so helpful. But from a social impact perspective, I would say that these people from developing countries, people with college degrees, if what it does is it gets them in the pool with everybody else, that's beneficial from a social welfare perspective. That these are the people that would have been on social assistance, or most likely needed the help the most. So another thing we look at is heterogeneous treatment effects. Here we do something very simple. We train a model to predict the probability of reporting a new job in the control data using a gradient boosted machine. We look at the high employability, medium employability, and low employability people, and we find that the people who were predicted to have low employability have the highest treatment effects, and both in absolute magnitude, but especially as a percentage. So we are helping the disadvantaged people with this. Finally, as you all know, I'm also very excited about surrogates, and I think we have that going on at this conference too. That's something I've worked on. Here, this seems like maybe a natural place where maybe you could use surrogates. You have one sample, the LinkedIn match sample, and we can see both people clicking on the LinkedIn certificate and the jobs. We have this bigger population where we could also measure, just from Coursera log data, we can see if anybody clicked on the profile and came to Coursera, even though we don't know whether we have the job, and we don't actually have a way to match that, or at least we don't have an easy way to match it. They haven't provided it to Coursera. So we could try to match these up, but here's the problem. The problem is that first of all, the LinkedIn people are different than the other people. And in the bigger population, in order for someone to come and click on your certificate from LinkedIn, and we can see the referral comes from LinkedIn, you had to have a LinkedIn profile. But we also don't know who among this sample of hundreds of thousands does and doesn't have a LinkedIn profile. So we can't even define a subpopulation who might be more similar to the LinkedIn sample. So we really don't have a way to connect the things. Nonetheless, we still report the correlations, even though we don't think you can do them together. If somebody clicked on the people who got views on their certificate from LinkedIn to Coursera had a 0.37 or 0.38 greater chance of getting a new job, so a very large effect. So there's a big correlation between getting clicks and getting a new job. And there is also a treatment effect of being exposed to the nudge on getting views. But I don't think you can multiply the numbers together. And I will stop there. Thank you. And so we're going to do all the questions together, correct?
Yes, at the end, yeah. All right, there's a little clicker right on top. Yeah, it's right here. It's just forward.
Great. So it is a delight to be here and also an honor to share the stage with Susan, whose work I also admire. This project is going to take us on a little bit of a detour, but I promise there will be a digital experiment. So just wait for it. So we're going to think about developing country cities, which are growing in population pretty dramatically. And we're going to focus on the city of Lagos, Nigeria, which is the largest city in Africa at 22 million people. And it's projected to become the world's largest city by the end of the century. In Lagos, 19% of trips are by car. And I want you to guess what fraction of trips are by public transit. Any guesses?
40s.
Okay, we're getting some large numbers, 40%, 80%. 5% of trips in Lagos, Africa's largest city, are on formal public transit. The vast majority of trips happen on informal transit, on a bunch of minibuses. They are basically VW buses that are each owned by different operators that ply the whole city and basically deliver most of the transportation in the city. In Lagos, these are called danfo, but they're common around the world. They're common in Africa. In most large developing country cities, this is how people get around. Now, I should note that this may seem very different from the experiences you've had in your cities, but it's actually not unique. So on the outskirts of New York City, this is also how people get around. These are dollar vans that serve the places that the subways do not. And if you look at the visions of our cities from tech companies, a lot of them look suspiciously similar to how developing country cities get around. Thank you, Elon Musk. So amidst this backdrop, so given that this is how cities get around, a lot of these cities are investing in formal transit. This is Lagos's bus reform initiative that we'll be studying today, which introduced 40 new routes and 820 new city buses over a period of 4 years. For a sense of scale, this is as big as San Francisco's bus system, but they launched it from essentially nothing. So this is a pretty massive program. And it's just a drop in the bucket. So by our measures, there are 759 informal routes with about 75,000 minibuses. That's 10 times more minibuses than there are cars in the New York City subway. So this is a massive system. This formal investment is really small in comparison. That's not unique to Lagos. Dar es Salaam spent $382 million building a bus rapid transit system with beautiful buses, shiny lanes, and it serves about 1% of trips. Most people still travel by informal transit. So our project today considers how does the informal network respond when governments spend money building out these formal systems. And so we're going to do 3 things here. The first is that we're going to collect a bunch of data as this formal system is rolling out to understand how the informal system is adapting around it. Second, and this is where the digital experiment comes in, we're going to try to figure out how commuters value those changes. We're going to find that wait times are going to go up, and it seems like prices may have gone down. So we need to know how commuters value waiting. And if they value waiting a lot, then this could be a negative effect. And so we'll show a kind of innovation here that allows us to do some experiments that are digital in a context where people don't have smartphones or internet connections. And then we'll use a simple model to come up with a welfare estimate. So by way of background, so the system may sound chaotic, but it is in fact organized. There is a drivers association, NRUTW, which does manage the terminals, and it has some role in clarifying where the routes are. But beyond that, drivers are basically entering on their own free will. This is similar to Uber. You can sign up, you can get a van, and then you can get a permit to drive one of these routes, which is fairly easy to get, and then you can start doing that. About 88% of drivers drive only a single route. And most of the vans are this kind of VW minivan, and it's outfitted with an extra row and some wooden seats, and so it can fit about 14 passengers. Some drivers hire a conductor who helps passengers get on and off and also collects fares. There's also some smaller and larger vehicles, but this is kind of the modal one. Amidst this system, the government spent a lot of money building fancy new terminals and buying new buses. The buses travel on the same routes as the informal ones, and these serve the entire city. These were rolled out progressively over a few years, and so we're going to study what happens to the informal drivers that were serving these routes as these formal buses start running on the same routes. I should note that the stops are not the same. So you have to decide before you get to the bus stop whether you want to go on the informal bus or the formal bus. So for data, the formal system is great. You can look at every time somebody taps in, they pay for their bus ride. We have all of that data. That's the same type of data you might get from any wealthy city that also has a public transit system. And so we could do a lot of experimentation and learning from that data. But as you might guess, that really doesn't cover much of the transit in this city at all. And so most of the work of this project is actually collecting data outside of that digital data and actually understanding this network. Now, this is not data that existed before. Even the government doesn't know what routes are being served, the number of passengers, the fares that are being charged. And so one thing we did is we hired enumerators to travel around the city to find every route they could find. They found 759 routes. They spent about 30,000 kilometers traveling throughout the city on these various routes. That built us a network map. We then stationed enumerators to count departures at bus stops and at terminals, so covering 278 routes, 79 bus stops, over 13 rounds, as these routes were increasingly served by the formal transit system. We also surveyed drivers, and I'll show you the wait time experiment that we ran. So pretty much a big endeavor, and the reason is a lot of what's interesting is not happening on this digital platform. So let's think about the welfare effects of this with a simple model. You have a commuter who wants to take a trip from some origin O to some destination D, and they're choosing what mode M to travel along. They get some amenity value from the particular mode they choose. They dislike waiting, and they dislike paying prices, and that's relative to choosing not to travel at all. Now, if we introduce a new mode, that could potentially have a different amenity. So a nice shiny bus that has AC, we might like more than a crowded, smaller VW bus, but there are also maybe differences in waiting and price. Overall, the welfare impact of introducing this new mode has these components. So one component comes from people who adopt the new mode. So people who are now taking the formal bus, we can compute how much utility they get based on the proportion of people who are now taking that. But then also, the people who continue to take informal transit, they may be getting a different level of utility because their prices and their wait times may be affected. And so we're going to measure those effects, And then we're also going to consider how they value those impacts in the wait time experiment. So first, to get at these impacts on the informal network, we're going to basically use this staggered rollout and run a regression of this form, basically looking at what happens to an individual route as that route is served by a formal bus, where we're using the other routes that are in the government's plan to eventually be served as control routes. And we're going to do this effect over time so we can see the dynamic effect as it happens. And so this is what we find. So if you are on a route that is served by a new formal bus, and it's been open for less than 3 months, we don't detect an effect. But once it's been open for 3 months or longer, we start to see a negative impact on departures. So informal buses are less likely to be traversing these routes. Their departures fall by about 29 to 41%. And that means that wait times are going to rise by about 3 to 6 minutes. This is pretty robust. We've tested it in lots of different ways. And we also have done some placebo tests to suggest that we are seeing this decline in departures. Not super surprising. We also see some evidence that fares are falling. So these informal buses seem to be reducing their fares by some amount, though this evidence is a little bit less precise. So we're not going to hang our hats on it too strongly. And some of this seems to be happening more on routes where the formal service is cheaper. Okay, so two results that we see these different effects on departures and wait times. Now we want to think about, is this good for commuters or bad? If fares have gone down, but also they have to wait more, what is the net effect for our commuters? And so one way to think about this is imagine you have a commuter who's come to the bus stop and they want to take their trip. We offer them some payment, S, to wait for an amount delta t. Now, if they like waiting and they don't care about time, but they really care about money, they might accept that offer. If they really care about time and they're in a hurry, they might reject that offer, even if S is high and delta t is small. And what is that utility? Well, they'll get some common utility here. If they reject that offer, they'll just leave when they would have left anyway. They'll pay the price they would have paid anyway. And they have some preference for leaving at that particular time. If they accept that offer, their wait time will have gone up by delta t, and the amount they paid would have gone down by S. And so we can see whether they accept this offer for a random set of S's and delta t's and trace out how much commuters value waiting. And so this is, we can do this as a discrete choice model where we basically model this choice as a function of all these parameters. So there's some really cool related papers that have used rideshare offers. So if you look at Lyft, for example, and I think Uber is doing this too, where you sometimes get a menu of options that give you different wait times and different prices. And so if you use that variation from that, you can estimate wait times. This is a context where very few people use rideshare and very few people have smartphones. So we can't use variation from, or if we use variation from an app like that, it'd be very selected. So we're going to design an experiment that allows us to estimate something similar with a context of very low-income people who do not have smartphones. And what we did has a few steps. So we recruited about 640 commuters who live near bus stops. Now, you can imagine we could have gone to people while they were at the bus stop and just said, hey, here's an offer to wait. Are you willing to talk with me, fill out this nice IRB form, go through this recruitment process? You can easily imagine the type of person who'd be willing to talk with us would be people who really don't value their time. Right? So we would find, oh, magically, nobody in Lagos values their time. This is fantastic. We can make them wait as long as we want. That would not work well. And so we had to recruit in a more careful way. We recruited people at their home on weekends when they're less likely to be stressed. And we told them that we were going to have an agent stationed at their bus stop, the bus stop they usually commute through, on weekday mornings for the next 3 weeks or 5 weeks. We randomized the duration here. And what they would find in the morning when they came to the bus stop is someone wearing this fluorescent hat, who's a part of our program. And they could come to this person. Now, the person who has a fluorescent hat had to have a smartphone. So our enumerators had smartphones. And on their smartphone, when your participant walks up, they would have a secret clock. And so this is the way the secret clock works. At a particular time, that clock is going to show a random number. That random number is going to encode what time it is. And as the time changes, that random number is changing. So every minute, we display a new random number. Now, the participant can walk up. They don't need to have a smartphone. They can have a basic phone. And they can read off the code on the enumerator smartphone, and they can text that to our shortcode. When they do that, our shortcode is going to say, well, based on the random code that you sent us, we can authenticate that you were here at this bus stop at this particular time, and then we'll send them an offer. So one, we'll send them some amount just for checking in, so 200 naira, and then we'll give them an offer. In this case, if you wait 5 minutes, we'll send you 400 naira more. So then time passes. This clock on the enumerator smartphone keeps updating, and then if the participant decides not to wait, they can just go and go on their merry way and do the rest of the day as usual. If they choose to wait, they can text that updated secret code to our number, and that authenticates that they've been at the bus stop waiting for the given number of minutes. And then if that number of minutes exceeds the amount that they were asked to wait, then they get the reward automatically sent via airtime directly. So this offer has 3 components. So one is this check-in offer, how much you're paid just for checking in at the bus stop. This we randomized between people. So each person at the beginning of the experiment was randomized into one group that got either 200 naira, ranging up to 1,000 naira just for checking in. Then each day, each person got a random weight offer. And that weight offer was a combination of a number of minutes and an amount. So this is what we see if we look at those weight offers together. You can see they range from about 3 minutes up to 25. And we tended to draw from the distribution where the weights were a bit smaller, but we did want to check if people were willing to wait these large number of minutes. And you can see that people are willing to wait more when they're paid more, and they're willing to wait more when the wait is shorter, which is a very good thing that we found that. But we basically are going to use this underlying data to estimate this willingness to wait. Now, before we do that, we have a problem. And the problem is that when we asked these people on what days they actually traveled or what days they intend to travel, they tell us that they travel a lot. So they told us that they traveled 80% of days. If we look at our check-in data from the digital device, we don't see 80% of days. We see 55% of days people have checked in. And so this raises this big question of maybe if people are in a hurry, they're not willing to go check in with our enumerator. This is a big problem when you're estimating the value of time. It's a problem for us because people are not going to engage with this process on days that they're busy, but it's also a problem if you're using information from rideshare apps. If, for example, you're likely to use a rideshare app only when you're in a hurry, then we'll estimate values of time that are inflated relative to just general value of time for transportation. So what do? 1, we survey this planned and actual travel. 2, we randomize this check-in offer. And here, what I've plotted is this check-in offer against the proportion of days traveling. The top line is the planned travel in the first week. And you can see one that's high. It's about 80, 90%. Also, it's flat. So randomizing the check-in offer does not seem to affect the days that people plan to travel. But the second line shows us the proportion of days that are checked in. And that is not flat. So when we pay people more to check in, they're more likely to check in with us. So we're capturing more of their trips, or more of their trips. The other pattern you notice is that if we plot the fraction of times that people accept the offer that they were given, conditional on checking in, we see that line decreases. And what that means is when we're paying people more to check in, they're checking in on days when they're less likely to want to wait. So we're resolving some of this selection problem. So once we've gotten this variation from this randomization of the check-in, then we can model the selection. We use this kind of standard selection equation to model both the decision to check in, which depends on people's willingness to wait, and this random check-in offer, and the expected value of the wait offer. So when we do that, these are the estimates we find. So the value of time is about 19 naira per minute. That corresponds to about $1.42 per hour in US dollars. If we had not done this selection correction, if we just looked at the data of the acceptances and rejections, we would have gotten a number that was less than half of that. So we would have had severe bias based on this. Another thing we could have done is we could have just asked people, hypothetically, we gave them a list of options of would you be willing to wait 5 minutes for a certain offer and so on. So we asked hypothetical questions. This is often done within transportation. There, when you ask people, they say they value time a lot. They say that they value time a lot more than they actually do. They said $3.48 per hour, essentially. And so this just suggests that measurement of the value of time is a bit nuanced, and how you measure it does make a big difference. So finally, we can link this to welfare effects. So these numbers are preliminary, but they'll give you a sense of what we find. So if you just look at the change in mode that comes from rolling out these new formal buses, we see a large positive welfare effect. Introducing this new mode also applied competitive pressure to these informal buses that resulted in, by our measures, some reduction in price. That would have boosted welfare even more, but it also means that wait times went up. And so this is a context in which, because we've measured how much commuters value that, the wait time decline is actually a more severe hit to the utility than the gains from this increased competitive pressure. So far, we're finding still positive effects of this intervention altogether, but it does suggest that we need to think carefully about these spillovers. So let me wrap up with a few thoughts. So one is that it's often governments are thinking about public transit as something they do in isolation. These results are suggesting that really you have to think about how the private services are going to adapt around what you do. 2, cities are going to need to manage private or hybrid transportation systems that are a mix of public and private. That's very clear in developing country cities where the informal market is so huge and it's really not possible to replicate that scale with public investment at this point. But it also seems increasingly likely to be true in wealthier cities if you think about interactions with Uber and Lyft and the increasing possibility of autonomous vehicles and fleets of private buses. Then, more relevant for thinking about digital experimentation, I think there's a few notes to take away from this. One is that often the data that's easiest to gather may not be the data that is most informative about what we want to know. Sometimes you have to go out and collect messy data that's not digitized in order to understand your market. And then 2, especially if you're working with low-income groups or people who are not fully online, it's possible to do hybrids of digital platforms with some human oversight in order to get some of the advantages of digital experimentation. So you could think about running an experiment like this with only humans, and they'd have to have some recording notebook of who arrived at what time, and you'd have to trust that they would calculate the times right and pay the people right and not make mistakes, that would be extremely hard. But if we just did a solely digital platform, then there'd be a lot of people we would be omitting from this. So this hybrid allows us a bit of the best of both worlds. It allows us to serve low-income people while also making sure that we're getting good compliance and we can do a fairly sophisticated experiment. But anyway, very excited to see the rest of the work that you have been working on. And as I noted, it's a delight to be here. I love this conference. So thank you for having me.
Great. That was awesome. Okay, yeah. Okay, so I don't think the session had a formal name, but I'm going to ex post name it. Careful thinking about externalities, because I felt like that was kind of a theme that came out. So let me just start there. One thing I was struck by was that all the experiments that you talked about, there was a lot of like careful attention to like how things would potentially go wrong. Like if I didn't measure it in a certain way, or I'd be worried about this sort of thing happening. And my question is that something that you've kind of come to just from experience of having done a lot of things, or do you have kind of heuristics that you use to sort of anticipate problems before they happen that kind of guide designs?
Yeah, I guess I think Dan was more interestingly careful probably, but I think, yes, like if you start thinking about trying to study getting people jobs in general, it's very hard to track them. And in the US, it's hard. We don't have a lot of administrative data, and certainly in other countries that can be difficult too. So like survey biases are a huge problem. And they restrict you in so many different ways. They restrict you from like just how much things cost to follow up on people. Then you need more power because you have to do bounds if you want to be careful about it. But generally, they make you keep things short. And using LinkedIn to track people's jobs for the part of the population that does keep their profiles up to date, it really lets you study the effects over a longer time frame, and that also gives you power. Actually, I showed you the picture on one of them of how things change over time, but in both of them, you get these graphs of the gap between treatment and control just being very persistent. So so I think that's a nice insight that at least if you're interested in studying that population, it just dramatically reduces the cost of your experiments. And even I had studied another organization called Year Up that did training for low-income people, and I couldn't figure out how to power an experiment with budget. Actually, later Larry Katz managed to put the IRS data together with them, and then was able to analyze the thing. And I did not persevere to do that. So it takes a lot of perseverance to get that kind of data. So yeah, kind of finding that. For me, it was like finding some natural way where I can do it at scale. But then, of course, once you start paying attention to selection bias, we realize that also put limits on the ability to use fancy methods, which work in some contexts but didn't work here.
Yeah, I think it's kind of a mix. So you develop over time, and I'm sure everyone who's run an experiment here, you develop over time a spidey sense for where things can go wrong. But this was a case where we ran a pilot, and that's when we noticed that, intuitively it makes sense that this check-in selection was going to be a big problem, but I don't think we didn't have a plan for addressing it until we saw how bad it was in the pilot. And so I think adapting to conditions as you see them and being very attuned to how things are evolving is important.
Excellent. So, a theme in kind of Susan, this is more for you. A theme in the labor econ literature on helping any individual worker is like this very first order concern about crowd out, right? That you're helping, robbing Peter to pay Paul. But I think my personal view is sometimes economists take this logic too far and think that you can't improve upon it by helping anyone. And so I wonder kind of how do you think about that tension between yes, we can make the equilibrium better, but it's not just sort of benefits are coming at the expense of someone we're not helping.
Yeah, so there was a bit of, like, I'm motivated with the workers in Sweden getting laid off, and a lot of this is like older manufacturing workers who had all this specific human capital, and so, but at some level there is like a fixed number of those jobs, and there's not a great way to make those people have as much value as they did before. They've been doing this job for a long time. So, but then one of the reasons we focused on these growing sectors is there's a theory that, you know, there are plenty of jobs, and in fact, if it was probably the limiting factor on outsourcing in Poland is the number of workers in Poland, and so you would continue to grow there. Of course, maybe that's at the expense of someplace else, but if Silicon Valley is overheated, you know, maybe that's, from a global perspective, that's a good thing. So. So I think that we picked places where that crowd out was going to be less of an important problem, or where there were whole categories of workers. And so generally we think probably that it's not just outsourcing in Poland is limited by the number of workers, but actually if we had more IT people, they could build more digital services. So like the whole world needs to kind of digitize, and that'll go faster when we have more workers, and they'll start businesses and do other things. So I'm not worried about it there, and that's why we picked it. But of course, there is congestion in a different part of the market, which is like, say, the LinkedIn recruiter resume processing part of it, because one of the mechanisms here is likely, you know, you're changing your resume and that gets you flagged, and so you weren't getting flagged and your resume was never even getting read, and now it is in the Coursera experiment, and maybe even in the Dare IT experiment as well. So there may be, like, at least in that past, there might have been like a fixed amount of recruiter attention to process these workers in the short run, so there would be crowd out. Of course, maybe we're going to have, you know, robots reading the resumes also, but, you know, so maybe their attention gets expanded. Who knows? But yeah, so I think, like, obviously in the short run there is some crowd out, but I think there is elasticity of growth as well.
Excellent. So I think we could actually do maybe a few questions from the audience if we want. Do we have the microphone floating around? Oh, great. Okay, great.
Oh, sure. Hi, this is a question for Dan first, and then maybe for both panelists. Like, since you have this sort of structural model embedded in your paper, and because it's buses, let's pretend the old buses were red and now we have blue buses. How do you get realistic sort of substitution patterns? Do the routes kind of serve as nests? Because, like, it's almost like the canonical example where the substitution patterns produced by something like a Gumbel would be kind of unrealistic. And because you have sort of staggered changes in the availability of modes, do you observe that the substitution patterns you get are realistic? And for both panelists, like, do you have thoughts on experiments being used to validate these discrete choice models? Because they are, by construction, a lot more hard to evaluate.
Before Dan answers, probably, like, a lot of the audience didn't get your joke. So if you weren't trained as an IO economist or as an economist at all, so Dan McFadden won the Nobel Prize for connecting models of consumers' choices about buses, modes of transportation, to the multinomial logit model, and he showed how you can estimate consumer welfare, and that was all about expanding the BART to Berkeley in the early 1970s. So the red bus, blue bus problem revolves around challenges in doing that. So take it away, Dan.
Yes, we have a yellow bus, blue bus problem. I don't think it's as severe as one might be worried about. Essentially, the problem would be if, imagine you take all of the same buses and the choices actually remain identical, but you paint some of them differently, which doesn't actually change people's utility from using them, then you might, if you've introduced a new option in your model, which then randomly gives people more utility. I think most of the utility in this model is not coming from the idiosyncratic error, so it's something that we're, like, aware of, but there's bigger stuff going on.
This is mainly for Susan, but people can chime in. So I published a number of papers in education, and I think this is really a powerful angle. how do we align education and training with employment? I think that's a great step forward. So I was wondering, how can we help job seekers run experiments that will help them communicate how their training could be relevant to performance in a job, to help them get jobs? So for context, in the class I teach, I actually have students use a tool we published. It's called AB Scribe, where they actually have to run qualitative experiments with the draft messages on LinkedIn or email with an LLM. And they run lots of micro-factorial experiments on what they say, how they ask for requests, how they introduce themselves to get an introduction. So how would you go about experimenting with not just the job seekers, where we give them examples or instructions for how they could then actually experiment on the ways they explain to an interviewer or a recruiter or someone who they want to chat with, how their training would align with performance in a job?
So that's a great question. I actually think John should answer this question more than me. So let me give a short answer. Maybe John will answer. John works with Upwork, and he knows a lot about what's happening here. So I think in general, like you could experiment similarly, nudging people to do things. Like you could run the same experiment I did, but nudge them to also send certain cover letters and so on. I do think anybody who's a professor is a recipient. I think I'm getting one ChatGPT request today to be my research assistant from someone whose interest in physics perfectly aligns with my interest in causal forest. But so I think those types of things may be more short-lived, and then there might be, and so people might tune them out a little bit more. So that's something where I think the Coursera certificate is something that you're hoping that you might establish a long-run reputation for its value. But John, do you have more to add?
I do. Yeah, I mean, I think one of the things that's challenging if you're telling like an individual job seeker, hey, do this and you'll get good results or something, like say the thing you're advocating works really, really well, has like a 20% lift or something. But if they're only sending a few job applications and the baseline is pretty low, that's like a really hard inference problem, and it makes it really hard. So you're almost kind of in the world of like a credence good, like trust us, this works. And this may be something where if you have a platform, say, that does the experiment and says, look, we've done this in a very rigorous way, this is likely to work for you, but it is going to be hard for you to infer that. That's kind of a hard thing, I think, to tell people, like explain this idea, but I think that's kind of the world you're in just for sort of like power reasons.
Yeah, I've got a question. Just thinking about, both of these studies, there's these different sources of uncertainty here. And I think this is true in a lot of, applied data science projects and industry as well, where, okay, yeah, maybe sometimes it's as simple as a single A/B test, but a lot of times we have other possible sources of bias. So like Dan, in your project, okay, we could be worried about the assumptions underlying this kind of staggered adoption analysis. We could be worried about the exact specification of the error term in the choice model. We could be worried about the selection effects. A lot of that, it seems like we have to reason about that very qualitatively as consumers of research, which maybe works when we hash things out over long seminars and review processes in the academic world. But I don't know, when there's so many inputs, how can you kind of simplify that or make that something that managers, policymakers can actually figure out where's all the uncertainty coming from here? Is it these standard errors because you have these 640 people, or is it really the lurking selection bias or the lurking violations of parallel trends, or what should I be most worried about as a decision maker?
It's a great question. I think simple simulations and back of the envelope things go a long way to really assessing. Especially when you're designing a project, really understand like where do you want to devote sample and resources. But I don't have any. You could do something fancy and simulate everything, but that's going to take much more time than you have in many of these settings. So I think just thinking through the pipeline and simple diagnostics can go a long way.
I'd say, in my lab, we do a lot of pre-analysis planning. Probably everybody hates me for it because it certainly slows things down. But just one of the tricks I have for planning experiments is to really actually simulate the data and write 2 PowerPoint decks. One that's showing your great results and then like defending them, and the other that has null results and explaining why your null results are informative. And if you and it's very hard actually as a researcher to put yourself in the position of your future self without some kind of trick or tip, because you just don't think about things. Like I checked my slides 6 times, but then like there was a typo that I immediately saw right when it was sitting in front of me in front of all these people that was not apparent on the airplane. You know, so I think there's like putting yourself in the position of the decision maker who's criticizing and really forcing yourself to go through that exercise before you run the experiment. And it sounds like, you know, Dan did that with a pilot. So pilots make that even easier because you actually are looking at real data, although you can't see treatment effects in there, but you can reason about them. So, and in my case, I mean, both organizations did adopt with enthusiasm, but there the decision makers were kind of also involved in at least they knew about the experiment and the experimental design, and so they had a chance to kind of express any concerns up front. Although, I mean, they weren't that involved, but you know, they were sort of enthusiastic about the exercise.
Great. So, Dean, that was kind of a depressing question, but I feel more optimistic after hearing those 2 very good answers. Well, thank you so much. We now have time for a coffee break. So let's thank our speakers again.